Good evening, calculus students. Today we'll be doing problem number 3 on the 2012 AP No Calculator. So, as with every good calculus lesson, today we'll be starting with the Hungarian word of the day. The Hungarian word of this class is
igaz,
which means true, because it's true that the more we study, the better we'll do on the calculus AP. Hooray! Now I've taken the liberty of rewriting today's problem on this page here so that I can show my scratch work easier. Alright, so the first thing to notice is that they give us this function f, which just looks like this, and they also tell us this function g, which is the integral from 1 to x of the function f. Now the first thing they ask us is to plug in some values into g. First off, g of 2. And when we look at the function here, we'll know that the integral is just going to be the area under the curve. And so for f of g of 2, we have a triangle with base 1 and height 1/2. And so it's important to keep in mind that this is going to be negative because it's under the graph. And the area of this triangle is just going to be 1/2 over 2, which gives you negative 1/4. Put the negative in blue because it's extra important. So that's the answer to the first half of this problem is negative 1/4. Now, next we're asked to look for g of negative 2. G of negative 2. And we can find this by looking at the graph of f. So we end up with a triangle of height 3 and base 1 and a semicircle of radius 1. Now, I've got this here. We already know that this is going to be 3 halves because of triangles, and the semicircle is going to look like this because the equation for the area of a circle is pi r squared, and we only have half a circle, so we'll divide that by 2. And this will add that to the 3 halves we have from this triangle, but since this is a no calculator section, we can just put a box around this. Hooray! And that'll be our answer. So let me just write that into the answer section here. Alright, now on to the next section, which asks us for g prime of negative 3 and g double prime of negative 3, or it wants us to tell them if that doesn't exist. Now, g prime of 3 is weird because g is an integral, and the derivative of an integral is just the normal function that it's being taken the integral of. So we're just going to look for the value of f at g equals negative 3. And to do that, we look back at the function, and we know that this line has a slope of 1, so at negative 3, f will equal 2. And so we know that value will just be 2. We can put that in here and box it. Now, with g double prime of negative 3, it won't exist, and I'll tell you why by doing a quick fun chart. So we've got f u n fun. Now, the reason that the fun chart is useful here is because at negative 3, f is increasing, f prime is positive, but f double prime doesn't exist. There. Easy answer. Increasing, positive, doesn't exist. So we'll put a big D and E in our answer section here. And we'll move on. The next part of the question asks for the points on the graph of G, where G has a horizontal tangent line. And we're supposed to also tell if that's a relative minimum, relative maximum, or neither. So G will have a tangent line when with a slope of 0 when f of x equals 0. And we know that f of x equals 0 at the points -1 and 1 just by looking at the function. So what we do know about these 2 points is that since f goes from increasing to decreasing, this point will be a rel max. And since f of x equals 0 here, but the graph doesn't change sign, this won't be anything. Sad face. So for this problem in the answer section, we're just going to write x equals -1 rel max and x equals 1 neither. Now the last part of the question asks us for when the graph of G has a point of inflection. Now, this would happen when f changes from increasing to decreasing or decreasing to increasing because of our fun chart over here. And we can see that on the graph here. We've got this point and this point. And so we can see that the graph of G has a point of inflection at x equals -2 and x equals 1. We don't have to say if this is anything. We don't have to say if this is in a relative extrema. We just have to say that it's an inflection point because of our fun chart that we've written out. When f changes from increasing to decreasing or decreasing to increasing, f prime will change sign. So we'll write in the answer box x equals -2 and x equals 1. Hooray! Now you know more calculus.